standards. Okay, first of all, we are going to discuss about what is ISPW. Okay, it is the ISPW is basically okay. Then what is ISPW? The ISPW is basically to place a controller in a control panel. You can see that there will be a controller in a panel for controlling the procedures or anything over there in the industry. You can see to place a controller in a control panel with a perfect condition using wires, relays and protective devices using the industrial standards. That is ISPW. That means with the industrial standards only it will be possible. Okay, that means the industrial standards, like I say, it is already in international standards or both in the Indian standards or another country standards over there. Okay, basically the panel wiring section is for basically for fixing up a controller with a suitable condition or the perfect condition. Okay, by using the wires, relays and the protective devices. You need to know that the protective devices is more important in the case of a panel wiring section. That means if the protective devices is not properly fixed or not properly working in that means the wiring, that means the panel is in a hazardous situation. Or you can see that if there is any fault is occurred over the industry, you can see the wiring or the whole the panel body is corrupted or okay, that is ISPW. Then we can look into how many, that means what are the components and the tools were used over there in the panel wiring session. Okay, first of all we can just look into the protection section. Okay, we can use, there is so many protection scenarios. You can see you know that about the fuses and the circuit breakers. Okay, for the case of fuses, you can see that in the fuses it is if that is broken, you can rewire that one, then only it will be working back. But in the case of circuit breakers, you can see over there, if the circuit breaker is break, you can see that the circuit breaker is basically you can just go back, you can just switch back to the previous question, then it will be start working. Okay, in the case of circuit breaker, there are different kinds of circuit breaker over there. Okay, first one is our miniature circuit breaker. Miniature circuit breaker means the MCBs. Okay, it is basically, you can see over there in your home, that is MCBs. Basically we were used in the home for the protection of our section by section protection over there. Like for one room there will be one MCB like this. Okay, but in the case of ELCB, it is an advanced circuit breaker for the protection, means like if the over voltage comes, it is drained to the earthing. If the earthing is not properly done in your system, that means done in your industry or in your home, that ELCB will not work properly. That means this ELCB is a voltage based device. But in the case of RCCB, it is the current based device. That means here there is no need of such kind of earthing or thing like that. Okay, over there in the case of RCCB, it is only work in the current basis, that means in the residual current basis. Okay, then in the case of MCCB, that means a molded case circuit breaker. In the case of molded case circuit breaker, you can see the MCB and MCCB both are similar in nature, but in the case of rating it will be different. Okay, but in the case of rating it will be different. MCB in the means of 0 to 100 ampere only occurred in the market. But in the case of MCCB, you can just have look into the rating of the MCCB. You can see that 0 to 1000 ampere. That means there is a wide range of ampere rating circuit breakers were obtained in the case of MCCB. You can adjust it to. That means if the case of MCB, you can see that 0 to 100 ampere, that is the fixed level. Like we got the MCB like 6 ampere, 10 ampere, then 16 ampere, 20 ampere, 25 ampere and 32 ampere. Likewise, etc. the different rating. But in the case of MCCB, you can vary or you can adjust the rating of your circuit breaker. Okay, then the last one, the fuses. We can see over there the fuses in your home. Okay, but in the case of home, you can see the fuses were used as KitKat fuses. But in the case of industry, you can see that the fuses were cartridge fuses. Cartridge fuses means you can see over there in the 3-pin plug or any kind of extension board over there. You can see there is a small, you can see the plug point. In the plug point, you can see the different kinds of fuses over. Okay, based on the classification, based on the application we have used in the protection level, the main classification is 3 types. Main classification is in 3 types. That is, first one is B type. That is for the home application. You can see over there, there is only the rating up to 0 to 63 ampere. But in the case of C type, you can see the medium industrial application, like the small scale industries over there. Okay, like the small scale industries over there, they were used up to 60 from 63 ampere to 150 ampere rating. Above 150 ampere, the D type category, that means the pure industrial type category comes, and these are the main classification based on the protection. Okay, then while we are moving to the panel, you can see that in the panel, basically it consists of 6 components, and first one is your base plate. Okay, all the equipments were placed on the base plate, and these base plate were fixed to the panel for the easy manner. That means you can panel wire in the base plate. In the outside of the panel, you can just place after the working, and after the work completed, that means after the base plate work is completed, then you can fix it into the panel. There is so many companies panel were occurred over there. When there is so many customized panel were occurred over there. The retail panel is the number 1 panel over there. Then the second one is the DIN rail. DIN rail, you can see over here in the first picture, you can see that is our DIN rail. That means all the components were fixed over there in the DIN rail. All the components like the MCBs and the PLCs and all the terminal blocks, relays, all the components were placed on this DIN rail. Then the next one is duct, the wire laying duct for the protection, and the conjectural feeling were avoided by using these ducts. Okay, inside through this duct, the wiring is occurred. Then about the cooling fan for the cooling system. For the cooling system, you have to use the cooling fan inside the panel. Okay, but in the case of heating system, you can see there is more conditions like heating. That means the cold climate or the heat climate, you can use the heating system also. That means in the cold climate, you can use the heating system also. Then about the lighting system, you can see in the panel there will be more like relays, the PLCs, like all the things over there. For the visibility of the panel, you can just place the lighting system over there too. Okay, these are the main components. That means that these are the main commodities were obtained in a panel. Okay, then about the rating gate, that means it is ingress protection. For selection of the panel, you have to just use it to the industrial conditions, and after that you need to fix the ingress protection rate. You can see over there in the solid case and in the water case, like the waterproofing and the solid, like the dust particle, you can just choose the devices by using this number. Okay, here there is an example for that, IP65. It means that your panel is in the dust type, no ingress of dust, and 2 to 8 hours of protection. That means the whole the dust were protected to 2 to 8 hours in a day. Then about the 5, protected against the jets of water. That means the overpressure water is protected over there in the panel. Likewise, you can choose the different kinds of panel by using these IP standards. Okay, then about the basic tools and components over there. In the case of basic tools and components, you can see the first one is our wire or the cables. Okay, for the case of wires or the cables, you can see that there is so many different sizes of wires. Here we were using basically inside the panel, you can use 1 mm square or 1.5 mm square over the panel wiring. Then in the case of 3-phase supply or the loaded supply, you can just use 2.5 mm square for the loaded supply or the 3-phase supply. There will be already the standards standards, that means wiring color code over there also. Okay, for the wiring color code, you can see that according to the Indian standards, you can use for the phase you can use the red color, for the neutral you can use the black color, and for the for the earth you can use the for the earth. Then there is the control wiring and the DC wiring too. For DC wiring we have to use the yellow or blue color wire over there. Then for here there is no insulation is provided. That means for the joining purpose you have to use the connectors. No insulation or nothing like that. Okay. Then in the case of ferrule. Okay. In the case of ferrule, you can see in the case of ferrule, it is like the figure, this yellow figure. That means after the wires you can see the ferrules. It is for the indication or the labeling for the wires. You have to use the different kinds of ferrules over there, like printed ferrules. That means the customized sleeve ferrules and this kind of ring ferrules over there. Then about the bootleg. Bootleg is to fix the stripped part. That means for the stripped part and into the ports you can strip a screwdriver and crimper. This is used for the stripping purpose and screwdriver for the fixing purpose. And about the crimper. Crimper is used for basically used for fixing up these bootlegs. Okay. Then about the terminal block. You can see the terminal blocks is like basically the connectors. So you can just have to look into the video and you can see the terminal blocks over there. That means terminal blocks is connected as singly and the connected way. That means use a bus bar and it will be shorted to form a connected way. These are the main tools and components we were using the panel. Then about the field parameters input. You can see about the digital and analog over there for the input side. Okay, in the case of digital inputs, you can see there is push buttons. Okay, push buttons and proximity sensors. Okay, these are basically the digital inputs like 0 or 1 condition only. Then about the float switch and the selector switch, these were providing only the 0 and 1 condition. That means the on or off condition. Then about the analog, you can see the analog here there were pressure transducers like pressure transducer. Then about the thermocouples. Pressure transducer is basically for measuring the pressure and it will convert it to the electrical signal and it will give to the PLC. And then about the thermocouple, it is basically used for the temperature measurement, and this temperature measured and it will be converted to an electrical signal, and this electrical signal were given to one PLC. Then about the level transmitter, basically were used for measuring a level of an instrument. Okay, it's clear? Okay, then about the next one, the outputs. Okay, for the outputs you can see there is also digital and analog. For the digital you can see the relays, motors and the pilot lights and the solenoid valves. In the case of solenoid valves you can see there is only on and off condition in the case of small solenoid valves. But in the case of analog you can see the control valves over there. That means you can adjust the level of the valves. Then it will be occurred over there. Then these are the main outputs over there in the field parameters. Then about the wiring section, then when we are coming to the wiring section, there will be two wiring section over there. First one is your power circuit and second one is your control circuit. For the power circuit, you can see that in the case of power circuit, we just go through the PLCs, we have go to the classification like with SMPS and without SMPS. Okay, for the case of with SMPS power supply, we have to use power circuit with SMPS. That means the PLC is with 230 volt AC. But in the case of 24 volt DC, you can use the without SMPS power supply over there. Okay, without SMPS power supply. That means you need to use directly 24 volt is given to the PLC. Okay, but in the case of power circuit with SMPS, that means there is an inbuilt SMPS inside the PLC. Inbuilt SMPS inside the PLC, and you need to give the 230 volt AC to that PLC, to that particular PLC. But in the case of without SMPS, that means there will be no inbuilt SMPS over there. That means you can give only 24 volt DC over there. Because of our PLCs or any controllers operating voltage is 24 volt DC. Okay, then about the control circuit. Control circuit, these are two types. First one is sink type and another one is source type. Source means it is basically a positive supply. That means if we control like a input and an output, that means an AC input and an output, you can see that output is working by using the positive supply from the source. Okay, then about the negative side, that means you can see that the whole circuit, that means the all charges were synced to the negative side. Because of that, we can see that the sourcing is positive and the sinking is negative. Okay, then about the power circuit with SMPS, we can just look into the picture of power circuit with SMPS. You can see here, this one is your power circuit with SMPS. We can see over here, we have to give directly the 230 volt to that particular PLC. Okay, here you can see the line and neutral directly we are given to the particular PLC. That means that PLC is working with 24 volt DC. Okay, that means there is an external SMPS too, because of we have to work the relays and the input cards and output cards and like the cooling fan also. For that we have to use an external SMPS over there. In any panel you have to use the external SMPS. If you have PLCs with SMPS or without SMPS, you have to use an external SMPS over there, because for that, for the purpose of connecting the relays and the input card and output card over there. Okay, these are the connection of a power circuit with SMPS. You can see the line and neutral were directly connected to the PLC and the emergency stop switch were placed in between the line and the PLC. Line and the PLC, or line and the in between all the components in the PLC, all the components in the control panel. You can see if your emergency stop is pressed, then these whole components like PLC, SMPS, cooling fan, all the system were gone off. And here you can see the emergency stop indication. While you are pressing that emergency push button over there, then there will be two contactors over there. First one is NC and another one is NO. You can see that while we are studying in the ladder logic program, you can see if you are giving an on pulse, your NC will activate. NC will activate it and the conducting will be closed. Conducting will be closed. Opened. That means it will not be conducted. Then in the case of emergency stop NO, you can see that if your NO is activated, then it will be conducted. Because of that, that emergency stop will indicated. Okay, these are about the power circuit with SMPS concept. Then about the power circuit without SMPS concept, you can see directly your power supply. That means directly to your line and neutral where it comes to SMPS, and from this SMPS your PLC and all other components were work. That means here your PLC is with 24 volt DC. So that this SMPS is powered to that PLC for the 24 volt DC. Okay, these are the without SMPS. Similarly, the emergency stop condition, like I say in the previous slide, these are similar for the emergency stop condition. Okay, then about the control circuit. You can see about the control circuit. I am just saying about the sinking means the negative supply. Okay, sourcing means positive supply. We have to look into where I have to given the negative or positive supply. Okay, you can see first of all we can just look into the sourcing input conditions. Here in this structure you can see this is a PLC processor input card and a PLC processor. You can see there is optical isolation or transistor based isolation over there. Transistor based optical isolation over there. You can see over there will be diodes over there. Okay, here you need to conduct your diode is only conduct in the case of forward biasing. For providing the forward biasing, you need to connect the P region as positive and an N region as a negative. Okay, here you can see that the C, that means the common range, common, and there is input 1 and input 2, and there will be a common over there. In the case of common, the diodes positive will connected. Diodes, that means diodes P region is connected. Two diodes P region is connected. For that, you can just connect through this C, the positive supply. That means positive 24. Because of we are connecting the positive to the common, it is named the sourcing input. Because of we are connecting the common as positive, for that you can say it as sourcing input. Okay, we have to connect the common as positive 24 because of your diode is for the diode being forward bias. Forward bias for the P region we have to connect the positive, and for the N region you have to connect to the negative side. Okay, then in the case of sinking in, you can see your diode PLC. You can just look into the wiring diagram of your particular PLC. You have to connect. You can see over there if your diode is in reverse or in an inverse manner. You can see here diode is in inverse to the previous slide. That means here the negative side is, that means the N region is in the downward direction and the P region in the upward direction. You can see here the negative side is come to the common. For that we have to supply the common as negative 24. That means the minus 24 over there for the common. Okay, minus 24 for the common. Because of that we have to use the common. Here the common comes as negative 24 because of, we can say that it is a sinking input circuit. Okay, likewise we have to connect for the sinking in PLC. You can just have to look into the PLC wiring diagram. There you can see whether it is sinking input or sourcing input over there. Okay, then next one about the output side. You can see that in the case of sinking output, here we can just similar that the common. For the common you have to place the negative, then it is sinking. If you are providing positive, it is sourcing. Likewise here you can see the negative supply we have to given in the common side, and this common side, that means this negative is comes in the output and the output 1 and output 2 as a loop for completing a cycle. For completing a cycle you have to use the negative to the common, and you can see the output 1 and output 2 has come the same value we have to given to the common. Then only it will take as a loop. Okay, for the sourcing output, what will be there? For the sourcing output, you have to given the common as positive 24 volt like this. Then your output 1 and output 2 have to come like this as plus 24 volt. These are about the wiring section. Then you can see to the video, and after that we have to explain over there what will be the wiring connection or wiring standards over there. You can just look into the video, and if you have not clear, you can just look back to the PowerPoint and you can just visit that. Okay, thank you and have a